Hello everyone, my name is Thomas and welcome everyone to tonight's Bay Area Search Meetup. I'm working in eBay in the search backend, and we're always looking for great speakers, and if you guys have any good speaker to recommend, just let me know. And also I'm just one of the organizers. We also have Ranjan and Brian. Where's Chris? Well, Chris actually organizing the food for us. He's at the back, he will come up. So before I introduce the speaker, as usual, do we have anyone want to make any announcement?
Was eBay hiring?
Exactly. We're always hiring. We're always hiring.
Oh.
Yeah, just send us resumes.
So if you're interested in work, after you listen to Tim's talk, if you're interested in search science,
Exactly.
you can talk to Tim or I afterwards.
Right.
I'm Brian Johnson.
Yeah, Brian Johnson. Any more announcement?
Yeah,
Come on.
Hey, if you're interested in working for a startup that works on a new way of doing search, completely different from what we're probably going to talk about, then talk to me after the talk. Thanks.
Yeah, Chris wants to make an announcement.
Did Brian already make the jobs announcement?
Yeah, he did.
Yes. So if you talk to Brian, you should talk to me. I wanted to actually pitch something completely different. So on October 11th and 12th, we're having a hackathon here in, well, probably the other room over there. But it's kind of a neat one. It's called Opportunity Hack. And it's basically, we bring together people who know how to write interesting code, and we bring together people with interesting problems from like nonprofits and charities. And then there's a whole like matchmaking process that happens. And at the end of it, you end up usually handing over some interesting software that they wouldn't have gotten otherwise, and you get to make a difference. There's a bunch of flyers up here. You get cool t-shirts. There's prizes if that motivates you. Give it a shot.
All right. I guess we're all done here. No, let me introduce tonight's speaker. So Tim Converse, Senior Director, Head of Search Science Engineer. He has founded a couple of startups before his company was merged into Yahoo. So let's give our tonight's speakers a round of applause.
It always works better for me to get applause at the beginning. Okay, thanks for coming, everyone. So my name is Tim Converse, and I want to explain head of search science engineering because that sounds kind of like an oxymoron, but I'll get into that. Okay, so just an outline of what I want to talk about. This is going to be really pretty high level, sort of a high level survey of eBay search, what we do in search science, how it works, and so on. And who we are, what we work on. And at the end, I'll just give a taste of sort of current projects that are occupying our mind. Just a little bit more about me. Actually, the whole thing is about me, but this first slide about me is just kind of my background. The reason I put from a web search perspective is I've worked mostly in web search in my career in Silicon Valley, and so commerce search and eBay is kind of new to me. I worked on Yahoo Web Search for quite a while, back when Yahoo was taking the back end of web search very seriously and competing at that. And then I went to PowerSet, which was a natural language search startup that did really deep parses of queries and documents. I'm laughing with my friend TS here because he also experienced it. By the way, this little arrow, the equals and greater than sign is my symbol for acquired by. So PowerSet was acquired by Microsoft, and I led the search summaries group for Bing for a while. And then I co-founded a very, very small mobile personalization startup that was acquired by Yahoo just last year. And I thought I'd be at Yahoo for quite a while, but then I started talking to old friends at eBay, and here I am. And really happy to join. So, let's see. Okay, so let's just motivate the problem. eBay search. So this is a little bit hard to see, I'm sure, but this is the eBay search results page, or a part of it. I hope that at least some of you had seen it before. But if not, you should go to ebay.com, and then there will be a search box, and then you can type stuff in the search box, and you can look for things, and it's great. So let me just break this down a little bit and talk about what the pieces of this are. You can't really see the query up there, but it's white gold earrings, and it's a query I'll come back to. It's kind of a poster child query for me here right now. So these are listings, and it's key that we at eBay have auction listings where people bid competitively on items, and we also have fixed price listings, which are the more conventional e-commerce approach of you pay some money and you get the thing. So you enter a query, you get these listings back, which you can dive into. I want to highlight a couple things on the left rail. So there are a number of ways you can refine your query other than just typing more things in the search box. One is you can drill down into a particular category for your query. You can ask for certain aspects, like what these things are actually made of. We offer a number of different ways to refine the searches. I'm not showing all of them, but related searches is one of them. And then finally, this is an issue that I'll spend a little bit of time on later. The sorting that I'm showing you here is kind of our relevant sort. It's putting things at the top that we think are most likely that you want to buy. But we can do other more deterministic sorts, like time for auctions or order by price and so on. And that raises interesting problems reconciling these two things. So I just want to spend also a little time comparing the web search problem to both e-commerce search and the specialized kind of e-commerce search that we do at eBay. So this famous sort of taxonomy of web search by Andre Broder from a while back, where he broke search intents down into informational, trying to get some piece of information, navigational, getting to a particular site, and transactional. And I hope it's no surprise that we focus mainly on transactional search. So yes, this is the kind of insight that you're going to get from this talk. People go to eBay to buy stuff. Okay, so, but people primarily come to try to buy something specific. They're looking to, they know roughly what they want to buy and they find it. But there's also a lot of sort of browsing, window shopping behavior that we want to support. So what are the inputs that go into the search engine? Obviously, on the web, it's web pages. And for us, it's listings. And it's important that it's not products. They're listings that particular sellers have made, and I'll delve further into the difference and why that's important. Web pages are mostly unstructured text. There have been various attempts to inject structured data into web pages and get people to conform to certain schemas for having their web pages be structured in a way that search engines can understand. That has not penetrated as much as evangelists for those approaches would like. For eBay, it's semi-structured, or I should say sort of intermittently structured. Sometimes there's some structured data that the seller provides and does not. Crucially, and this is a crucial difference, we don't have any kind of link graph. So all the graph analysis that web search engines do with PageRank and authoritativeness and number of links, and especially anchor text. I've seen the argument that if you want to make a web search engine, anchor text being the text in the link that points to another page, which gets indexed along with the page. I've seen the argument that if you want to build a good search engine and have the choice of indexing the pages or indexing the link text, the anchor text, you do a better job indexing the anchor text. We don't have that. We do have seller history and reputation. We've got some of the same user behavior, what things people have clicked on. But a very nice thing for us is that we have conversions. So when you build a web search engine, you put out your 10 blue links, people click on things and go away, and you don't really know what happened. You're hoping they're satisfied, but your measures of satisfaction are somewhat indirect. For us, conversions means that someone found something they wanted to buy, and we get to know about it, we get to know what they paid, and this is kind of crucial. So what kind of challenges do web search engines have in common with eBay and not? So we don't have to crawl anything. People come to us and put listings. So there's no web crawling, there's no link graph, and so on. Freshness is a huge challenge for web search and for us, but in a somewhat different way. Web search engines have to constantly be crawling the web and checking whether anything has changed. For us, we know about changes when people make them, but the inventory is very short-lived. We're constantly having to cycle through new listings. Understanding the query, it ends up being sort of a similar problem, and I'll talk to that a little bit more. web search engines often get their measures of authoritativeness by analyzing the link graph, which we don't have, but we do get feedback from buyers, and so we know what has happened with sellers, and that plays a role. Finally, we care quite a bit about pricing and value in a way that isn't as central to web search engines. Yeah, question?
What's the definition of aspect?
Oh, so if you have some structured data about a product, it would be attributes of that product, like say if it's a piece of clothing, the color, or in the previous example, the material the jewelry is made of, and so on. By the way, jump in with questions anytime. So I want to talk a little bit about scale. I won't try to compare the scale of eBay to the scale of major web search engines, but it's worth looking at. And by the way, this is not terribly sensitive information because I'm reusing information that was already made public earlier. So I've updated a couple things, but this is essentially a little bit stale. So on the order of 130 million buyers and sellers, 250 million queries a day, on the rough order of 1 billion listings that we have to search and index. I was talking to a guy who now works at eBay and used to work at the superconducting supercollider, and he said it was similar in one way in that they have about 100 petabytes of data from smashing particles into each other, and we have about the same sort of data stored. 2 billion page views a day, and then as of a couple of years ago, 75 billion of merchandise sold. Now, one key thing when you think about search is that most of those transactions resulted from a search. And so just to give you a sense of how much we care about search from a business point of view, imagine that you make a 1% improvement in connecting buyers and sellers into search. That translates to a very large volume of money in terms of transactions that happen. And most of that money is going to sellers, but a lot of it's going to eBay. So search is very central to the eBay business. So in terms of searching the web versus eBay search, the ecosystem is a little bit different. And honestly, the balance of power is a little bit different between the indexer and the users and the items being indexed. So largely, to a first approximation, people who publish on the web are sort of passively indexed. They put their web pages out there and crawlers visit from Google and Bing and other search engines, and the index gets built without too much direct input. There are cases where that's not true, but on eBay, sellers have to actively list, but they're also a paying customer, and so this means that eBay can impose requirements on the seller for whether they're able to list or not. But also, there's actual real dialogue between sellers and eBay about how we do things because they're kind of a business partner as well. Advertising is the primary model, the most important model for web search, and for us, it's the transactions that we have a piece of. The policy situation is a little bit different. Google can decide to demote people who are not. Google can decide to demote people who are not playing by Google's rules. They can't police the web, but they can, to some extent, police access to it. We can enforce policies at listing times, but we also have other sanctions that we can impose. So this is really a point of interest for me because I worked on spam, the problem of web spam quite a bit when I was working at Yahoo Search. And both types of engines have spam problems. And by spam, I mean when a publisher or a seller is doing something to actively game the search engine to make their results rise to the top. This is not fraud, and this is not trust. Here we're just talking in the eBay case of when a seller engages in practices where they're trying to move their results up to the top. We're not talking about sellers who commit fraud or who sell an empty box or anything like that. That is taken very, very seriously by eBay, and we have quite a large group of data science people who work on that problem, but it's treated as a separate problem in a sense. So types of spam that the engines have to deal with. Putting all sorts of unrelated keywords in the title and description is common to both search engines. In both cases, you have publishers or sellers who create many slightly different duplicates of what they're publishing or trying to sell to get as many of their products high on the list as they can. As I said before, there isn't really a system of links. There's not a system of links that we're crawling. There's something that's a little bit analogous. So web search engines confront the following problem. They're very interested in documents or sites that other sites are linking to, because this is evidence of authority and popularity. You can have someone who owns a whole bunch of sites, cross-linking those sites, making it look as though this is a very popular site, when in fact it's the same entity. The analogy here is you have people on eBay who will buy their own stuff, or bid on their own stuff, or click their own stuff, and it looks like there are many different entities interested, but there aren't. So it's kind of a behavioral analog to link spam. Cloaking, redirects, invisible text, these are all abuses that people use in web spam, not really applicable. As you get into the semi-structured data that I was talking about before, for eBay, this produces some unique kinds of structure to exploit. So these can actually be kind of amusing. One is fitment, and so fitment especially happens in the case of motors and cars and in other products as well. Sellers can say what their product fits, so that someone looking for something about that car will find parts that match that car. So you will have sellers who sell bumper stickers, for example, and they will list every single car that bumper sticker fits, which is every car in the world. Similarly, you can sell multiple items in one listing, and people will sell a bunch of expensive items and one spurious cheap item to rise in deterministic source by price. I'll show an example of that. Now, this slide's kind of dense, and I think of it as the whining slide. This is the slide where I whine about how hard this problem is. It's really hard. And here I'm talking about what's unique to eBay, not versus web search, but what's unique versus other e-commerce sites. So I talked earlier about the fact that that listings are not products. So what I mean by that essentially is we don't have an SKU associated with everything that we're selling. We don't have a unique product identity underlying the listings. Essentially, listings are free form in the sense that sellers can describe what they're selling, and this can be a very, very unique item. It can be a unique collectible or a unique something or other that the seller made. But this makes it hard to really know what the item is, and makes it hard to compare the value of different items. So this is a specific instance of sort of an open door policy with regard to selling. We do have standards that, some standards that you have to meet to sell things, and you can, if you're a particularly bad actor, you can lose your privileges to sell on eBay. But there's lots of description, lots of features that people put in, and incomplete structured data, and so on. And this is, so this is different from a straightforward product-oriented Converse search engine. The inventory is really deep. The inventory is really various, really heterogeneous, and idiosyncratic to some extent. And then we also have a lot of buyers who have, eBay still has quirks. We're trying to get rid of the quirks, but eBay still has quirks, and we have buyers and sellers who are very, very used to the existing behavior of eBay, which makes it a little difficult to change. Okay, I'll stop whining now, but that's part of what makes it challenging. Okay, so let's talk about search science. So this is the group that I'm involved with. And I want to stress that search at eBay is really primarily the product of three groups with data and help from many, many, many other technology groups. But primarily there's a front-end group that works on the user experience. There's a back-end group that does all the infrastructure and platform and anything that has to run in a super fast, scalable, performant, distributed way. In general, people in my group are not allowed to touch that code because there's the feeling, which is accurate, that we would mess it up. So what we do is we work on the algorithms that should should underlie search. We work on the machine learning models, we work on the data mining that supports this, and we do a lot of sort of the specification of how search should work to make it as good as possible for users. The things users really care about are relevance. Does the query have anything to do with the item that was pulled up? Trust, and as I said, that is largely handled by a different group. And finally, value in the sense of price, value for money, and so on. Now, let's talk a little bit about how we're judged, essentially, and when we know that we're doing a good job. One of the primary measures is essentially just revenue. And you might think that this is purely because we're being aligned with the business. But actually, if you think of a search engine like eBay, if someone comes and does a search and then buys something, that's actually a strong indicator of a positive user experience. People usually don't spend money on things that don't seem relevant to them. And so, in a sense, this is nicely straightforward, and I'll talk about that a little bit more when I talk about machine learning and targets and so on. But we judge ourselves by revenue. We judge ourselves by human judge relevance tests, where people look at the results and rate them for how relevant they are, and so on. Okay, so let's break down the work into sort of areas that we work on. And the first is, to a greater degree than other search engine companies I've worked for, we separate the problems of recall and ranking. By recall, I mean a user types in a query and a certain set of listings or items comes back. What should that set be? That's the problem of the recall group. Then the ranking group, given a query and a set of items that have come back, what order should they be shown in? And these are treated sort of as separable problems, and actually to an even greater degree than I would like, they're dealt with by separate technology platforms and architectures. Universal search is the term we use for everything on, pretty much everything on the search results page that is not the listings themselves. So earlier I showed you these refinements where users can refine by category or aspect, related searches. I didn't show you this, but often we insert other kinds of things other than listings into that flow of listings, like search guidance and so on. And then also we produce snippets of the page for some purposes. And so we have a group that kind of worries about the relevance of all that. There's a metrics group that I won't talk too much more about, and then spam, as I said before. So let's delve a little bit more into these tasks. So if you take a query and you're trying to match it to a set of items that you should return, the primary mechanism that does this is query rewriting. So you take a raw user query, you may tokenize it, clean it up a little bit, but then you transform it into a much larger query that is sent to the back end of the search engine. And among the things that this much larger query is supposed to capture is things like synonyms, plurals, direct mappings into these categories and aspects that you can also use for refinement. And this is a made-up example, but imagine that you typed in the query red dress. This can be sent just as the tokens, so if there's red dress in the title, it comes back. But it can also be broken down into categories and aspects that match the structured data. So you might end up with returning an item that just has dress or dresses in the title, and they've entered the structured data that says the color is red, and so it's part of the recall set. So I feel funny about talking about all this in front of Brian Johnson, who runs the recall group. The work here can both be enlarging the recall set and restricting the recall set. So an example of this is if you type in the query iPhone 5, the default behavior of the engine is that it will find items that have those terms anywhere on the page, anywhere in the title. In this case, you only want to match items that actually have iPhone followed by 5. So it should be a phrase. And you don't even want iPhone 6 with a 5-star rating to come back at all. And so this will never even make it to ranking, hopefully. You will only see items that have iPhone 5. And this can be done term by term, or more recently, we've taken to doing it for some queries for the whole query. You do a lot of analysis on the query, and then you come up with these expansions. And all of this is driven by lots and lots of offline data mining on user behavior primarily. Okay, so ranking. As I said, the task here is given a set of items and a query, the set of items returned by recall, how do you put it into order? And as with many search engines, this is primarily machine learned and partly not. And by machine learned, I mean that you train a function on a bunch of data, and then you verify that it's working reasonably well, and then you set it live. And when you set it live, every item is being ranked by this function that you trained. And at the end, you essentially simply sort the results that come back. And interestingly, we have these fixed price items and we have auction items, and we largely have to treat them separately. And there's a thorny problem of how to reconcile those scores and interleave them appropriately. So in general, when you have a machine learning problem like this, you're training on some target. That is, you have a bunch of variables that you know and one that you're trying to predict. And we've experimented with many different targets, and one of them you might imagine would just be clicks. So you have a number of features of the item. You have a number of features of the query, and then you have whether the user clicked or not. You're trying to predict the latter from all form. Another, and this is particularly compelling for us, is simply revenue. So you have a number of aspects of the query and the item and how well it matched, and then you have a dollar amount, which is how much the user spent, given that impression. That's usually 0. Sometimes it's not. And as I said before, this is a particularly compelling kind of target to train on, not just because it's aligned with the business, but because it's real evidence of user satisfaction. So if a user finds an item that they're willing to pay money for, then that's a good training example. I'm not going to get into an exhaustive list of the features that we use. Lots and lots of features that are about measuring the level of match between the query and the item itself, but also lots of measures of item quality, some of them driven by user behavior. If you have an item that a lot of people have clicked on, that's a good indicator. Many of our items you can are not just one quantity items. You can buy many instances of them. So if you have a lot of sales over impressions, clicks over impressions, and so on. All right, I talked a little bit about refinements and universal search. I'm not going to talk much more about that, except to remind you that these are the aspects of the page that these teams are driving. And I'll note that these can be computed offline, these can be editorially constructed, or they can be produced in sort of an online dynamic way. So are the useful refinements that people are clicking on and then buying, or just clicking on, and so on?
Isn't it slightly embarrassing that it says white gold is the search and over on metal it
Yes,
doesn't have white
yes,
gold?
I'm personally embarrassed by this. In fact, the reason I'm using this query is I was recently at a meeting with people from the other side of the business, including PayPal, and a woman came up to me, and it was one of those, oh, what do you do conversations, and I asked her what she did, and she asked me what I did, and when I said search, she went, in this kind of, what are you thinking way, and then she began to talk about this query. So I like using queries that we're bad at rather than queries that we're good at, because it focuses the mind. But her point was that this is actually a really interesting query, and I want to delve into it a little bit. So it's white gold hoop earrings. And one of her comments was, I think she's from Texas, one of her comments was, when a lady wants white gold, she wants white gold. And only then did I kind of step back, and I don't really pay much attention to jewelry. I don't think much about it. I probably would have described her as someone wearing silver jewelry, but then I realized white gold ring, white gold earrings, white gold necklace. So the passion of the customer was really clear here. But the reason it's an interesting query is that there are two color names in the title, white and gold. White gold is white, it's not gold. And if you really parse this, and I'm jumping the gun because I think I devote a slide to this, but it's an earring that's in the shape of a hoop that is made of a material. That material is white gold, and white gold is white. It's very natural that you would get gold earrings by a more naive analysis of this query, and we partially do and we partially don't. When we sat down and looked at the query, she was mollified because it was better than it had been because we recently shipped some improvements in high phrases.
So I have a question.
Yeah.
So the relevancy is not just the text relevancy, visual relevancy also is important. In this case, for example, you could analyze the image.
Yes,
you can
absolutely.
figure out, what color they are looking for and what color they're matching on the image. Sometimes the image is really tiny or bad or not very relevant. So you could, switch the rank. That's another aspect of the.
Yeah. So I'll mention this again, but two things we're caring a lot about right now are, for one, as you said, image quality.
Yeah.
Image quality is a indication of the quality of the listing and how appealing it will be. And if you can do image analysis to determine quality, that's a useful ranking input. But also, as you said, relevancy. Can you tell by inspecting the query what a relevant image would look like? And we're doing that, and we're working on it. Okay, so we have sort of internal metrics team for search science that is not the broader team that does A/B tests for eBay. This is really a metrics team to help us get better, create training sets, create metrics, scraping tools, and that kind of thing. And also this team does a lot of work on alerting when we have relevance problems. Okay, I talked about spam a little bit already, just to have a little bit of a different take on it. It's kind of interesting organizationally because, as I said, sellers are business partners, but they also are frequently trying to game the system. I shouldn't say frequently. A small minority of naughty sellers are trying to game the engine. And so it's just interesting from a company point of view what you want to do about that. And the alternatives we have to address spam by sellers are really four. We can educate sellers on what we consider good seller behavior, what is important for ranking in the engine, and what is sort of not permitted. We can block them. So when you try to list on eBay, there are certain requirements for what you can list and what you can't. We can stop a seller that is about to put in a spammy listing and have it never get into the system in the first place. We can sort of algorithmically neutralize sellers that are doing these things. It's hard to exactly neutralize the effect of spammy behavior. Often this ends up looking like demotion rather than neutralizing. What you'd really like is for it to be as though they had never spammed in the first place. So if you imagine a set of shill bidders, so these are bidders that are actually all the same company or person bidding on each other's items, you'd like to just not give credit for those bids. That would be the perfect thing. If you could identify them and take away the credit, then it would be just as if they'd never done it. In practice, that's hard to do, and it ends up being more like an algorithmic penalty. But what you really want is neutralization. Finally, yeah, go ahead.
I was just going to ask if you would elaborate on the advantage of shilling in an online auction. I guess it feels kind of obvious, but in an in-person auction, it's to create excitement in the room. Is that the same thing online, or?
It's to create excitement and maybe drive up the price, but even more importantly,
can have a reserve price, so.
But items that are getting sales or clicks or bids will, that can have a positive effect on ranking.
Okay.
So it can, I'm
Right.
not saying it does, but it could
Okay.
have a positive effect on ranking.
This is so much of a problem that there are laws against this, because it psychologically says this item is worth buying that people are bidding on.
Yeah.
And shilling's been done since the 1800s or before that.
Okay.
And as I say, aren't there laws? And don't you have to actually report when you find people that are shill bidding?
I don't actually know the answer to that question. I don't know what the legal implications are. I know that we're interested in detecting it and neutralizing it and so on. I don't know that side of the business, and I am not a lawyer, so.
We have a lot of overseas sellers, so even if it was a US law, it's not necessarily easy to enforce. Right? I mean, a lot of sellers are selling from China.
Yeah.
So you have to have a long arm.
Yeah, a long arm and a lot. Okay, so this is sort of there's a customer support group that does a lot of the enforcement and policy setting around this kind of stuff. What search science does is we can sometimes neutralize, sometimes apply algorithmic penalties, and also find and flag these things when they're happening and then pass them off to a customer support group. So an example of this is egregious duplication. If we find that a seller is creating many dupes where those dupes have just a little change in the image and a little change in the text, we can point that out, and then someone has a conversation with them, and the behavior either stops or it doesn't. So, okay, so I want to get into quite a bit of detail about exactly how we combat spam and tell you everything that we do. Okay, any questions about that?
Spam is typically done with Bayesian engines. Real spam, mail spam.
You mean detecting it?
Yeah.
It's especially with textual spam. With some of these things like bidding or dupes, you need different techniques which I've specified.
Clearly listed there.
Yeah. Okay. All right. So I won't get into too much detail in this section, but I just want to give you a flavor of the kinds of problems that we work on right now. Not sort of historically what we've done and what we've built up, but what we're particularly worried about. One of them is just sort of treating different frequency classes of queries differently. Now this is kind of a dense slide, but this is kind of the landscape, what the landscape of queries looks like to us when you sort queries by how many times they've occurred. Okay? So the query iPhone occurs many times. And queries that are misspelled or extremely long, or a copy of a book page that someone typed in might occur just once in a day. And this is kind of a rough picture of how the behavior looks for queries in these different query classes. So I've broken this up somewhat arbitrarily into head, torso, and tail. So head means the queries that occur with high repetition in a particular day. Tail means queries that we see once, twice, maybe. And torso is in between. So thousands of queries at the top. And as with anything like this, there's a real power law distribution here. There are tens of millions of queries that are just occurring once or maybe twice, hundreds of thousands that occur intermediately, and what we're calling the head is just thousands, but it makes up a substantial portion of the overall query volume. So this wouldn't necessarily have to be the case, but it turns out to be the case that the most frequent queries have the biggest result sets. So on average, the top thousands of queries have result sets that are in the millions. Tail queries that are very specific and very unusual might return only hundreds of items. You see a big difference in filtering behavior. And by filtering behavior, I mean that the kinds of refinements I was talking about, category refinements, aspect refinements, where a head query, a frequent query, gets immediately filtered about 5 times as often as a tail query. And this makes sense as a pattern of navigation. Someone shows up and possibly intentionally issues a very broad, vague query. Maybe they just want to browse around. Or maybe they don't realize how broad the query is, but they get many, many results back, and then they want to narrow it down. And also immediate conversion. This is how often does someone buy after having issued this query? And tail queries get about 5 times the immediate conversion that head queries do. And again, this is partly, not entirely, but partly due to a pattern of people issuing general queries, then refining either the query or using one of these refinement needs till they get to what they want. They issue a query, they find the thing they want, and they buy. So I won't talk too much about this, but there are real opportunities to treat these query classes differently, and we treat them very differently. In particular, with head and torso queries, you can really track a whole bunch of things about the query. You can track the categories that tend to be clicked when people issue those queries, for example. With tail queries, you basically have to do all the analysis just based on the query itself. And also, you might want to provide different kinds of experiences for head queries than for even torso queries. Maybe a more browse exploratory experience, or forefront the refinements more, and so on. So that's kind of a frontier area. I stole my own thunder with regard to this particular query, but we're very interested in getting ever better at understanding queries in the sense of decomposing them, breaking them up. And this is really natural language processing work. This is NLP work when it comes down to it. One nice thing is eBay has a strong commitment to machine translation because they want to do a lot of selling across borders. And this includes translating queries and listings to help people connect across different countries. And so in that group, we have a lot of NLP expertise, natural language processing expertise, as well as that expertise in our group. So I've broken out these stages, which are not stages of processing, it's sort of stages of sophistication about analyzing a query. So the most naive stage is you just treat a query as a bag of words or a sequence of words. And the next is to selectively segment the query and break it into phrases. In this case, you might want to break white gold into a phrase to insist that those tokens occur in that kind of sequence. And this is kind of in essence made up or a toy example. But in the end, you would really like to understand the query at the level of knowing what the product type is, detecting that a word denotes a style as opposed to something else, that this white gold describes a material, its color is white, there's no color equals gold, and so on. And so it would be difficult to do a really good job of returning results for this query if you don't get to a level of analysis like this. Okay, I'm jumping around in terms of problem areas, but a problem area that I alluded to earlier is the default experience is you type a query in, and then you see items in an order that we've determined in a really complicated way that we can't really describe to you. It's just best match is just here's what we think would be best for you. But you can do what we call deterministic sorts, which sort the results according to some particular field. So it can be the ending time of an auction. You want to see auctions that are about to end. It can be newly listed. You want to see the newest stuff. You want to see the cheapest stuff. You want to see the most expensive stuff. You want to see the closest stuff. The problem with this is, particularly because we treat recall and ranking as separate activities, you can just get very, very irrelevant stuff at the top if you haven't been able to sort by relevance. So here's, again, examples that make us look bad are really good from my point of view. So if you just type wedding dress, you get, you can only see the first listing here, but you get a wedding dress, recognizably a wedding dress. Now let's sort, and this wedding dress seems suspiciously cheap to me. It's about $79, but let's say you want to find an even cheaper wedding dress, and you sort by price, starting with the lowest. Now what you get, and this is an example also of keyword stuffing spam. 1 yard black, 2 row 3D rose lace fabric trim DIY craft sewing wedding dress L150. And This is some piece of fabric or trim that has has an initial price of $0.01. And so you see the problem. You want a very large recall set, and you want to be able to rank it intelligently. But then if you offer a deterministic ranking, you can get very irrelevant things at the top. There are a number of different ways you could address this. You could have different recall sets based on the sort. This is potentially very confusing. Someone looks at something in best match, they sort it by some other mechanism, it's disappeared. Where is it? Creating user confusion. You can restrict this, and you can tell people that you've restricted this. You can not allow people to do this kind of sorting until they've chosen a category first, which is a way that Amazon approaches this problem. So I'm not going to even advocate for particular solutions here, but it's a thorny product issue to get right, and it's a thorny relevance issue. Sorry, one other thing you can do is say, here are the most relevant ones, sort of by price, and then there are the other ones, kind of breaking the contract in this way. So that's an area that we're working on a lot. Another area is, I said that we do recall and then we do ranking, and then we rate each item and we sort them and we show them to you. The state of web search has probably changed since I worked on this, but when I worked at different web search engines, it was always kind of an evergreen project to have a third phase of ranking where you explicitly compose the result set, particularly for diversity. The problem is that if you just sort everything by its relevance, you may get a lot of seemingly duplicative items at the top. So instead what you can do is you do the recall, then you do the ranking. Then once you've done the ranking, you look at the result set, and you notice whether there's a lot of items of the same category or type or price, and you do some explicit moving things around to make that better. That potentially has two advantages. Advantage number one is that you increase the chance of hitting alternative interpretations of the query early. Intrinsically ambiguous queries, if the first 100 items correspond to one interpretation and everything is lower, then a user who has the other interpretation won't see the first item that matches what they were thinking of until way too late. If you do this kind of interleaving, you have a better shot at catching both users early. The other is it can just look better. It can look more entertaining and less duplicative. So another area of active research for us. Finally, personalization and contextualization. I won't say much about this, but I think this is something that the industry focuses on pretty heavily. It's an area that I worked on a little bit in my last two companies. So you can learn about the person and not just present items based on the query, but also based on what you know about what the person likes and doesn't like. And then at a much smaller temporal scale, you can look at what the user clicked on in the last query or what they searched on before, just within the last hour, 2 hours, whatever. And the idea is that this can be informative about their intents. And I'm especially interested in contextualization. Finally, this is a suggestion that was made earlier, but we're working on image understanding to help with ranking. So this is not quite image search. So you could imagine a more ambitious project that said, I have a phone, I have a camera, I have a MacBook in front of me, I want to buy one of these. Here's the picture, get me stuff like that. That's hard. There are efforts moving in that direction, but that's hard. An easier problem is take a query, maybe you analyze it right on the spot, notice that it has color words. Maybe you notice from a query that it tends to be associated with images that have certain color properties or color signatures or whatever. So what we'd like to do is just in cases like this, rank the things that seem to be a better color match or style match or pattern match for the query itself. Move those things up to the top a little bit and move these black shoes further down. And so have match between the query and the content of the image be Okay, so that's kind of a survey of some of the things that we think about day to day. Just one final note on what kinds of technology we use, because this may be a technical audience. Lots of use of Hadoop ecosystem and MapReduce and so on. We really like the programming language Scala. We, for those of you who don't know, you can think of it as kind of a somewhat more functional and more concise Java. It runs on the JVM. And we do a lot of the sort of big data MapReduce work directly in Scala. And we have a very, very nice platform that we use throughout search science that's built on Scala. And finally, for the stat heads, we use a lot of R, the statistical language, and in particular GBM, the boosted trees, gradient boosted trees implementation for doing regression and ranking and so on. So if you particularly like any of these technologies, you should definitely talk to us. Okay, so I think I'm ending a little early, but that's what I had. Thank you. I got some applause afterwards as well. So, question?
Yes, and on third ranking, how is it implemented? So, for say you have a recall phase 1, phase 2 you have the ranking, then phase 3, is it a term that gets added to the second ranking, or is it completely on the results side completely different?
It's really just a matter of looking at the result side and moving things around. So there's no new query. You just you have a ranked list, and you decide whether you like the order of that ranked list as a whole, and if you don't, you adjust the ranks of things. I realize I'm not being terribly specific, but I'm sort of probably beyond the limit of how specific I should be anyway. Yeah.
Yeah, and you said that the link is not important here, I mean link structure. I'm just curious that how internal link structure is important for the eBay, because you could link internally the page results to the different pages, and I'm not sure that how much revenue coming from the SEO or SEM. So if that's the case, like if you change the relevancy, let's say that Google is crawling the eBay site,
Yeah.
or Bing is crawling that, right? So how particularly these relevancy impacts the volume of the traffic that you're receiving? Because your optimization is based on the revenue per query, but the actual revenue based on the multiplied by the volume too, right?
Sure.
If the traffic goes down, the whole revenue goes down. So how do you maintain these link structure to stable to the like a search engine like Google or Bing?
So this talk is sort of overly driven by what I and my group work on day to day. So everything I've said is specific to the eBay search engine when you're typing into
Yes.
the engine on ebay.com and pulling up listings. It's of course very important to us how eBay ranks in other search engines.
Yes.
And there are people who worry about SEO for eBay, and they do all the good SEO practices about trying to rank well in other engines while respecting the other engine's rules. But it's kind of it's a different department that I don't know that much
I
about.
understand that part, but this implicitly the search relevancy impacts those ranking in SEO or SEM.
Sure.
So that's why I'm saying that how you control it, because those guys do not have any control on what you're doing, right? So it's completely different. Completely, the internal link structure is depending on you. How do you recommend the products or items to different pages? Because you have some at the end of the page, you have the recommendations, right? And also the relevancy of the, like a cosine similarity is different, like.
You often end up on a different page. So if you search on a search engine, a lot of times you'll end up on not just a regular search results page, but what are the pages called? Internally they're called landing pages, but you end up on a landing page. And it's got less navigation I think it doesn't have left navigation or doesn't have like right rail merchandising either. It's in line. And it doesn't show, it shows you like sort of part of an item and then a set of search type results. And then you can click from there to get into search more if you want to. But those pages were optimized for the search engine. But the rules change periodically. So when the rules change, those pages can be out of date, you know, in a wholesale manner, and then we'll change them. Oftentimes we'll work with search engines on the pages. We buy enough ads on, I mean, they crawl our site a lot, they send a lot of traffic nets. We also buy a lot of ads on their site, so usually there's some sort of conversation that goes back and forth. We're like the crafty sellers that we have, and they tell us, you know, we want you to do this and we don't want you to do that.
I can comment that if you're a naive search engine that crawls less than the big guys, it used to be a big problem for us at Blacko, that if you landed on an item listing and it's always expired, and eBay used to have a terrible experience for that, and they've actually improved it since. But nonetheless, we always transform those into product searches, and it's a much better experience. And that's a rule that I haven't done for any other website other than eBay. It's because eBay is so big.
But it's a fairly separable set of problems from the problems that we work on. And when you're searching for listings, I just meant that there's no interesting link structure between the listings to exploit or that indicates popularity. So, yeah.
Yeah, thinking about using revenue
As a target.
as a target, there's sort of an interesting conflict between your goals as a business and the user's goal and finding sort of the most economical solution to their problem. So, you know, the optimal user ranking might be different than the optimal eBay ranking.
Yeah,
And
well,
what happens there?
I mean, the most important thing is conversion. Conversion dominates the actual amount. So selling stuff at all is more important than the exact price that we sold it at. You could imagine that optimizing for revenue might drive up the price of things. It's helpful to have very value conscious customers who will not reward you if you do that. And certainly as a business, you know, there might be regrettable short-term benefit if the things you sold were more expensive, but that would not work out in the long term. And we are not on a program of trying to sell more expensive things. I think there's another whole interesting set of issues around price relevance, which is the price of something can indicate not only whether it's a good price or not, but whether it's the right thing or not. So,
Right, like your 1 cent
Right.
wedding dress items.
Right.
Yeah, they're just not right.
I mean, my gut feeling is that it's not as much of a problem as you would think. You would think that optimizing for revenue would mean that you were constantly showing people overly expensive things, and that doesn't seem to be what happens in practice, and it may be simply because we have sensible, thrifty buyers.
I mean, I think what happens is people don't buy anything, so revenue drops.
Yeah.
In your query intent slide, a query might have multiple interpretations.
Yes.
So when you issue that query to the index, do you issue multiple queries, or you just issue like the most likelihood query to get results?
We certainly rewrite queries in ways that the different rewrites represent different interpretations. So you can have different interpretations that are embedded in one of these big complex queries to the back end. Or to put it another way, there can be sort of ors in the expression that we send.
Maybe this can be addressed in the diversity also, right? Because every query has different interpretation for different users. So you may want to show like someone searching for Sony. So what Sony? Is it digital camera? Is it TV? Is
right.
Right. So.
Yeah, and I mean, to take an even more extreme example, a query like diesel, which can mean jeans or it can mean something automotive and so on. You can take the approach of trying to get the majority interpretation, or if no majority interpretation. You might be right, you might be wrong, you might be right for one user, not another. And yeah, it's a motivation for diversity. It would be nicer in cases where there's a real minority interpretation and a big majority interpretation to just go with the majority interpretation. But if you can't figure it out, or if there's no dominant interpretation, you're better off having it be diverse at the top. Yeah.
How big a role is natural language processing playing in understanding queries and increase the conversion rate?
It all depends what you think of as natural language processing, right?
So a long query, you do analyze the phrase structures. And
we don't do as much analysis as I'd like or that we'd like. There's a lot of structure that gets expressed ultimately in phrasing and phrase constraints. And certainly if you think of stemming and pluralization and so on as natural language processing, then we do a lot of that. Yeah.
So I'm kind of surprised that with the wedding dress sort by price from low to high,
Yeah.
an example, you would think that there would be low-hanging fruit there that you would have grasped.
I think there's medium hanging fruit that we're grasping right now. And I was intentionally showing you, a bad
Sure.
example. There are cases where we do well on such queries, even with price sorts. But as I said before, it's not just a relevance or science problem. It's also kind of a product problem with regard to user expectations. I don't myself have a solution to that I think is just inarguably the right solution from a product point of view.
Mm-hmm.
As I said, do you treat the recall sets differently? Do you?
So for web scale guys, whenever you have a sort by date option, they always have a solution to this problem, because otherwise it gets ridiculous. If you search for Obama and then you sort by date, you'll get the most, because so many articles mention Obama, you've got to do something to push up the importance of Obama.
Right.
And the results.
I'm just highlighting that there are several different sort of conceptual approaches to this, all of which have some sort of problem. Yeah, sorry.
I was looking at your measure for convergence, and based on his question, I was wondering about the worth of your brand. Your brand, to me, is you go to eBay to find something cheap. To go out there where you're bidding, you're finding the best bargain you can, and if you're for trying to sell for the most money, you're working against your brand.
Right.
How much is that worth to you?
Well, I was sort of slightly jokingly alluding to that when I said that we have some valued conscious buyers that help keep that in check. But I don't entirely, of course, agree that is the brand. I think it's also when you want to find something unique, or when you want to find something that you can't find anywhere else, and also when you want to buy pretty much anything. But now I'm just turning into
salesperson.
Yeah, which is not really my job, so I'll just stop. But yeah, I mean, our user base is, there are interesting differences with our brand and other e-commerce sites in our user base and their habits, and so I think I'll just stop there. Yeah.
I just wanted to ask you to talk more about what he was talking about, because my experience with eBay search is that I say, okay, I want to go buy an iPad, and then I don't sell the most expensive one. If I wanted that, I'd go to Apple.
Right.
I want a cheap iPad, and so I click sort by price, and then I've got about 200 people selling iPad covers for a cent.
Yep.
And so I'm like, okay, let me go to page 5. Or okay, I know I'm not going to spend less than $5 on this thing.
Yeah.
So I have to do the refinement myself. Why is that a hard problem? And you're saying with the search.
I'm just curious, have you tried, this probably doesn't work, have you tried researching by category?
Yeah, but sometimes I don't know the category.
Yeah.
So I have to do all these searches, figure out the category, or people will put something into, a puzzle. Which is that a game, or is that, what is that? What category is that?
There are a bunch of things going on there. One is miscategorization by the seller, and sometimes even intentional miscategorization by the seller. Another is sort of the general problem of what we call accessory pollution, which is you do a search for a thing, and instead of finding the thing, you find things that are accessories for the thing.
Bumper stickers.
Yeah. What the reason that's especially challenging is it's actually usually an ambiguous query where some of the people issuing that query are beginning a navigation to find accessories for the thing. So if someone types in iPhone, some of those people are looking for iPhones and they see cases and they think, what is this search engine thinking? They can't even get it right that I'm looking for an iPhone. Other people type in iPhone and because they're beginning to find stuff for their iPhone, they see cases, they buy cases. And so it's often an intrinsically ambiguous query where we run into that problem. Now, I don't want to start the whining slide over again and say, oh, this is so hard, but it's the intent that you come in with, may not match the intent of people who are buying a lot of stuff. And finally, there's an interesting tension there between, and this is where trying to judge ourselves by selling stuff can go awry, because if someone types iPhone and they get cases, they may, for one, go away, but for two, it may affect their perception of the engine. So there's relevance in the sense of the user's sense that you got it right versus showing stuff that ends up selling. And iPhone versus iPhone cases is one of those situations where, for many people, if you type in iPhone, the fact that you're not showing iPhones gives a perceived irrelevance, even though a lot of people do exactly that in buy case.
We've done a lot of experiments though where we've narrowed things down, right, in the auto-applied constraints. And it's usually hard to get a good result out of them. Oftentimes we're very enthusiastic about them internally, right? Because from a precision versus recall or quality versus quantity standpoint, we're like, yeah, this is definitely better. This is modeling the user's intent better. But then we don't show stuff and we actually make less money and we sell less stuff.
Yeah.
It's not always the case, but we've had a lot of experiments like that. Sometimes it's easy to explain. Sometimes you have to dig quite a bit. So we did an experiment one time where if we thought you were looking for a camera, you search for Nikon, and we put you in, if you search for, I can't remember what the model was, Canon Rebel. And we was, oh, Canon Rebel, you're looking for a digital SLR category, we're going to put you in the digital SLR category. That's what 95% of the people buy for that query. And we did, and we got user feedback, right? And some of it was spot on. Like the guy wrote in a long feedback that says, I know what you're doing. Most people that type, Canon Rebel are looking for this, looking for a camera, but I do that so that you show me cameras and I can click on lenses in the left nav, and then I want to buy a lens for a Canon Rebel. And if we put you in the dominant intent for the query, then it makes it harder for the people with the minority intent. So some people buy those cases that you're trying to skip over. And if we take them away, then some of them don't know where they went.
Yeah.
But that wouldn't be good that give the user option, like go, it applies the category classification first, and then recognize, suggest these are the categories, and the user has an option to select the categories among them, right?
That's what you're complaining about. I think it's an excellent complaint. Right? It's like, I don't want to do this. You guys do the data mining and figure out that, I entered a query and I should have constrained the price and maybe constrained the categories and applied some filters and shown me the right results. I mean, what you're asking for ultimately is you want the I'm feeling lucky button and you just want to see one item, that's the one you want to buy.
No, I just don't want to have to scroll through hundreds of things that I know I don't want, before I can finally find the first one that maybe, and then the next one, it's like, all right, some of those, and all right, finally I found the first real iPad that I want to buy.
Yes. This is due to lack of the category classification. If there is a category classification this engine applies, then you won't see those accessory cases in most of the cases that you sort by the price, you see the irrelevant results comes up. because there's no category
I
classification.
don't think category would solve it completely though. Some categories are pretty general, and so the accessory and the thing would be in the same
It
category.
depends on the
that's true.
taxonomy. How do you define
Yeah,
the
Sure.
taxonomy?
Like we have a chainsaw category. In the chainsaw category, it's all things chainsaw, right? Chainsaws, chainsaw, you know,
Lubricant,
blades
yeah.
and lubricant and sharpeners and everything chainsaws in the chainsaw category. There's not a chainsaw accessory category.
Right.
Right.
But that accessory is like an example, you have multiple categories, you have to define the levels. Without the level, it's so broad, everything can fall into one category, right?
Yeah.
The object.
I think a lot of us like to think that if I wanted
We
to
should
yeah,
have a deal.
have
But
a-
I'm gonna move on to this question.
Could you elaborate a little bit on the universal search, especially the category thing? How did you generate those categories in the search result page?
Want to take this?
We have a team who actually the human expert team help on generate those kind of hierarchy. It's not purely generated by machine. It's not like I assume you're asking whether they are generated by machine or they're not purely generated by machine. Of course, we have some machine learning and data mining like to send feedback to them, to work with them to determine whether this makes sense or not, or even suggest. But there are certain I can do between the human expert and
Yeah, but suppose I have a very long tail query, there are a lot of search results in different categories, and how would you generate those categories? Like, what are those categories?
You mean the categories that are showing up on the left?
Yeah, yeah.
Those are actually for the ones that are available as refinements are there are items in the recall set that have that category as a label.
Yeah, I think about the top categories, like related categories instead of the aspects.
You mean how are we generating the taxonomy, or how are we categorizing
Instead
it?
of generate those categories. Like given a query, you have a certain number of categories are showing on the top of that panel.
Yeah.
It's based.
It's based on what
almost
came
solely
back.
on the recall, but the order of the categories is based on, so that the counts next to each category are based on supply for that query, but the order is based on demand, user behavior.
Yeah.
So an obvious example that product search engines, right, Amazon comes to mind. An obvious advantage they have, like you said, is the fact that they know what unique products are, whereas you don't. So how hard is it to figure that out? I mean, can't you enforce that sellers put in SKUs, or can't you like machine learn them so that so you can build out your family of products and effectively sort of review listings better?
Part of eBay's business is in categories that are very SKU driven. If you go to consumer electronics, for example, we really should know those SKUs. If you go to collectibles, the whole idea breaks down. We may want to do more encouragement and more enforcement for people to enter that kind of structured data. It would certainly be nice if we had SKUs for all the products where that makes sense. That would be a great thing. We don't want to change the business into a business where everything we're selling is described by an SKU.
So related question is, do you do any post-processing of the search results, like classification or clustering for the search results? If the search results are very similar, would you like cluster them into?
Well, you can think of what I was talking about the diversity as sort of being clustering. It's certainly post-processing of the search results. So we start with the search results and then we do some processing based on similarity of items, or we have that capability.
We have done experiments in the past where we take the intents, make like a category, and say, oh, here's 7 digital cameras, here's 7 lenses. And we'd split and show some of each thing and then do a ... and click here to see all. Yeah, in general, if you put an interstitial page between people, the more pages people have to go through, the more they drop off. So it's hard to make. It seems like a good idea, but it's hard to make it work.
How's
Yeah.
the processing load for the second ranking and third ranking? I mean, how's the latency? Is there any
How's the
latency of the results coming back after second ranking or third ranking?
Oh, well, in general, we strive for sub-second latency for the whole end-to-end process.
Is it expensive on the large candidate set?
The way we're doing re-ranking is not terribly expensive. It's not, and you don't have to re-rank the whole result set.
Okay. The first set,
Yeah,
you have the result?
you can just re-rank the top. It's fairly cheap. Yeah.
A real hole that I've encountered personally is negation. If I want to get, you hit the accessory problems, but I'm looking for the install disks for a Mac.
Yep.
And Macs are sold, I have to go through hundreds of Macs, and the install disk may be called DVD, install,
Yeah.
blah, but you can't necessarily say not the machine. And the talk that was given at eBay last time about eBay talked about how you drop words like real.
Yeah.
And other things.
And for sale. And,
yeah.
and,
well, your pair was real airplane as opposed to model airplane. And how do you get that semantics, or is that beyond you?
The general problem of negation is really hard. That's all I'll say about that. You can have special query syntax that eliminates items that have a certain
dash
term. Yeah, right. But you know, I'm not really looking for Max. I'm really looking for something else that's doing real NLP.
So you mentioned that you're excited by, I think that's the word you used, contextualization, or interested in contextualization. Is there any thinking behind why you would limit that to only user behavior signals from the immediately preceding query?
I was really just using that as an extreme example. That the closer you get to the present, the more clear it is that the intents line up. The further you get, the bigger picture you get. So that's the spectrum for personalization.
The spectrum for personalization is from very long term,
yeah, right,
up until the immediately preceding query.
Yeah, and it's much harder to predict in general what a person is going to do at this moment, based on lots of knowledge of that person, than maybe it is to observe what they're up to right now. This is not, I mean, I'm not making a terribly deep or well-researched claim. I'm just saying that observing immediate behavior can be powerful. Yeah.
Hope this is not offensive. Talking about
Better
evaluation, have you ever compared your effectiveness of your search engine with your competitors like Amazon or Walmart by inputting the same query and comparing?
We do that in human relevance tests. It's a little difficult to compare when the inventory is very different. But yeah, we do lots of comparisons all the time. And I'm glad that I was able to answer it.
Yeah.
Yeah.
I crawled it.
On the metrics slide, you mentioned that that team was doing some work on intelligently finding places where search relevance is breaking down.
Yeah.
Are you able to speak any more about kind of how that process works?
Just lots of real-time monitoring of the results and looking for expected results and expected characteristics of the result sets. But that's.
And what do you do when you find it?
Call somebody and wake them up at 3 in the morning? No, just kidding. Yeah.
During the phrasing phase, all the examples I saw was basically an ER at least, but I'm sure there's a lot more going on than negative regression. Do you have a knowledge graph? Do you do other methods of phrasing?
There are lots of different kinds of data mining that we do that ends up cashing out in a phrase. That's about all I can say about it.
Question on query understanding, annotation, segmentation.
Yep.
Do you use external sources apart from product information like Wikipedia to create, to do the segmentation?
There are lots of places you can get interesting phrase data. We're especially interested in cases where the phrases are implicated in behavior. And so we're very, very interested in phrases from our own query logs, but we use other sources as well.
Do you use NLP, like Open NLP or Stanford NLP to create those phrases?
We use some of those open NLP tools, especially when doing offline experimentation and analysis.
I had one question about the actual ranking process. I'm assuming everything's gradient boosted trees all the way down. But for instance, if you chose a category along with a query, that might affect sort of deeply particular terms and how they're going to weigh into the query. And so, you know, your standard BM25 model on the terms against the text might change. Like in the wedding dress thing, if you also checked off the dresses category, you might not care whether, you know, how often the term dress showed up in the title.
Exactly, yeah, right. That's a great idea.
And how do how do you alter the text query to take that into account?
That question is getting kind of too.
Okay. Sure.
Yeah.
Yeah.
Maybe we can chat in general terms offline.
Is it okay with all your organization working on the presentation of such results, like creating the fonts, image size, etc.?
There's a lot of work that goes into presentation and lots of testing of alternate presentations. That work is not actually happening within this group. This group is kind of a back-end focused group. And there are applied science researchers who work on the front end as well, who do that kind of work.
Do you do anything with like real-time contextualization of search results, or trying to interpret what meaning? You know, if I search for rebel cannon and then I click on the one link that is a Civil War cannon, it's like, oh, you want arms, not a piece of electronics.
Yeah, absolutely.
And then my next search might. I guess you can't do anything about that.
Yeah, I mean that's a very exciting area of research for us. That kind of thing. I feel like I'm getting bigger as I go. Yeah.
How do you see the future of the product search?
Now you speak really
Product search. You mean this kind of search, or you mean specifically products, not listings?
Specifically product search. Like comparing to their like Google Shopping, you know, so that's one of the search that comparing to the other. Like,
the only answers that are coming to mind are just incredibly flip. That you hold a phone to your head and we ship you what you really wanted. I'm sorry.
Let's say someone's trying to build a search engine without any user information, like all the start problem. So how do you suggest, how do you see that new product is coming and competing with the current
Well, that's the piece of the problem that search engines have addressed best. That is, search engines typically address every user and every query like it's a cold start problem, right? I think the real frontier is in the other direction. Using more context, more personalization.
How about the navigation?
How about navigation? I think browse and search experiences should become more integrated than they are. They're typically separate. You're either in browse mode or in search mode. And I think there should be more sort of fluid adaptation to what you're doing right now that tilts it more toward browse or more toward search. Certainly, these head queries that we deal with, you can argue should be treated primarily as a browse experience. So there's a question in the back? Or are we running out of time?
So just let's have the last question, and you will stay a little bit longer, right?
Sure.
Yeah. So then we can chat offline. Last question.
Do you by any chance use Apache Spark for clustering, or
do we what?
Use Apache Spark for clustering purposes?
I don't believe we've used Spark for clustering as yet. We have?
Yeah, in other groups.
In other groups, okay. Not in.
Paris,
What's that, sir?
I'm talking about it in the conference next month.
Oh, okay. If you'd like to know more about the use of an eBay for clustering, Chris Sievers will be talking about it. In where and when?
Paris.
In Paris. I would advise that everyone go to Paris to learn more about it. Okay.